Hi everyone, I'm Angie Kippelen for the FlexTech Alliance. Today I'm in Phoenix, Arizona at Flex, the premier event for flexible and printed electronics. Joining me now is Professor Bernard Kippelen. Hello.
Hello, how are you?
I'm doing great. Professor Kippelen is from Georgia Tech, and you head up the COPE Center there. Can you tell us a little bit about that?
Yes, absolutely. So COPE stands for the Center for Organic Photonics and Electronics. It's a center that's located at the Georgia Institute of Technology in Atlanta, in Georgia. And it was established about 10 years ago with the goal and the mission to create an ecosystem and environment in order to promote and grow that emerging area, which is organic and printed electronics. It was really motivated because this is an area with great potential, but one of the challenges is that it's multidisciplinary. And so we realized that no team, no single investigator could do that on his or her own, and that it was really important to build teams. And we thought that having a center like COPE would provide that environment to build teams among faculty and with students in order to tackle some of the challenges in organic and printed electronics.
Well, it seems like it has a very valuable role out there as far as, R&D and research and helping the emerging technologies. What are the kind of scientific principles or what kind of technology are you actually focusing on there?
Yeah, we have a very broad focus because we want to be as inclusive as possible. And because we are a public university, one of our mission also, of course, is in training the future workforce that will be working in these areas. And so our focus is on research. We also have unique infrastructures that allow us to make breakthroughs and game-changing advances in these areas. And so to get into the details of these areas, we focus on technology areas that range from information and communication technologies to energy and the environment to healthcare and as well as security, sensors, monitoring, because the foundation of what we do are these organic or carbon-based materials that, in contrast with crystalline silicon, can be printed onto any substrates, especially curved or flexible substrates. So that can lead to a new generation of products that not only have functionality, but they have completely new form factors compared to conventional circuits or products that are designed from hard materials. So we're working with soft materials, and the great potential is that we could go to devices at extremely low cost. And so you could think of putting intelligence on a lot of different products in very high volumes, so in the billions of products using these organic semiconductors.
So let me ask you, is the center following any particular model of innovation?
Yes, I mean, this was part of our vision and one of the motivation for creating the center, and that is currently and organic and printed electronics is a perfect example where it's all about networking and team building and creating new value chains. And for this, you need to assemble teams, including people from academia. We have a lot of brain power, brain capital that we can share, but we need to team up with industrial partners because they know what is viable in the marketplace. They remind us of some of the hard problems. And so we try to transition some of the discoveries that we make in the lab and at the same time be a resource to industry through our expertise, but also through the facilities that we have on campus. Nowadays, the pace at which innovations happen is increasing, and the resources that you need for these innovations are quite significant. And so you have to share resources. No company can just build and have all these resources in-house. And so the model we'd like to apply is one that's often referred to as open innovation, where companies don't necessarily have in-house expertise in these opportunities that they see, and that's why they come to us, because we can help them build these opportunities inside the company. They get to know our students. These students can become potential hires, and then create the in-house expertise that's needed. So it's all about creating networks and covering the full value chain, from the discovery of new materials to the processing and patterning of these materials into thin films, to the fabrication of devices and the characterization, all the way to packaging, subsystem, and also brainstorming with our industrial partners to identify new markets, because this is an area where it's not just about creative, disruptive technology, but it's also trying to apply that technology into completely new market segments.
Well, I know an underlying theme for the FlexTech Alliance is, of course, the networking opportunities there, and I know that's a great model for anyone to move ahead and progress and develop emerging technologies. I want to thank you so much for your time today, and I'm looking forward to your paper presentation tomorrow. So I know the FlexTech Alliance is very happy to have you on board as one of their speakers, and we look forward to hearing from that tomorrow as well. Thank you so much for joining me today. I appreciate it.
Thank you. My pleasure.
In Phoenix, Angie Kippelen for the FlexTech Alliance.